Hello, everybody. So I'm going to introduce first myself. I am, as Thomas Sipos was defining me, the Taliban of the milestones. So I work for CINEA, and a project officer there. And well, the idea, after seeing all this interesting conversation about the PCI, how to get the status of PCI, how to implement PCIs, then let's get a little bit dirty and see a bit of the specific technologies that have been implementing in PCIs, and also we invited colleagues from HORIZON 2020. So, because the idea also, when we try to make the grid smarter, is that we try to innovate also in order to be more efficient in this development of the grid. So, well, the first part of it is going to be a set of presentations. And of course, since we're here in the house of LS, we will start with them. So let's start with Janko and Emil, please, if you can join.
Okay. Oh, it's yours.
Thank you, Eduardo. As said, my name is Janko Kosmach. I'm with LS, and I was project manager of the dynamic line rating sub-project of the Synchro grid. And my aim is today to speak a little about what the dynamic line rating is and how we implemented this technology at LS. First of all, the dynamic line rating is a power system support operation tool that calculates transmission capacity of the power line. And it uses dynamic weather data to calculate those values. And this is considered smart as an alternative to the dynamic calculation. Is basically a static value which is found in a standard for the overhead conductors. So the static line rating is simple. You take the conductor and you read the value, which is basically calculated with certain conservative weather values. Alternative is dynamic line rating, which uses weather data within the span of the power line, and then it calculates what is the ampacity for that particular span. But as power line has many spans, you have to know weather conditions along the whole power line in each span. And then, based on the calculation, you decide which is the bottleneck of all the spans in the power line. And of course, you have to know weather conditions for all the time horizons you are calculating the ampacity. Now, the basic structure of the dynamic line rating system is as follows. First, you have the system that calculates implementing certain DLR algorithm, and for that you need line conductor properties and weather data. And weather data is obtained from mesoscale model and from weather measurements, which improve the modeled data. And then you exchange the results with SCADA system. And of course, you get some information also from SCADA EMS system, which is basically the current of the power line. This is how it looks when you install weather station. This is quite special weather station. It has ability to survive 3 weeks without any sunshine. And we have great results implementing this technology with extremely good availability of data that are then fed into the weather assessment and forecast module. And finally, we come to the end user of results of the dynamic line rating system, which are operators in an operator room. And if you want to have DLR really in use, you have to implement deeply those results into the SCADA system. And what does DLR gives us? It gives us substantial increase of the capacity on a yearly level between 15 and 25% median. And it gives us also, it gives us improved safety of operation of the power line, as these algorithms take into account what is the allowed maximal temperature of the conductor in the span. Conclusion. Dynamic line rating calculates transmission capacity. It should be performed for every span. At LS, we use an indirect method, which means we have no measurements whatsoever on a power line. We don't measure temperatures or tensions or similar values, but we rely on weather data only. Yes, we perform measurements like temperature, but just to verify the quality of the DLR. And of course, the main information here is the quality of weather data. As said, we use mesoscale weather data, which is then processed on a microscale, but in combination with the weather measurements. And of course, results must be integrated into the SCADA system. Typical results, as said, 15 to 25% increase and 2 to 8% capacity, which is not static, but it is lower than static due to the weather conditions that are not favorable enough to reach the static value. Thank you very much.
Hello, my name is Emil Cek. I'm also from ELES, and I was project leader of the Slovenian part of the project called Virtual Cross-Border Control Center. Virtual Cross-Border Control Center, in short VCBCC, we call it. It's a set of IT and telecom solution which make it possible to bring state-of-the-art operational tools to LS and HOPS operators. Let me emphasize some achievements which I would like to present. These are the common application voltage VAR scheduler, VVS, which is used at LS and HOPS National Control Center. We have communication platform for exchange of operational tools between TSO, DSO, and distribution companies in Slovenia. And I would like to point out also upgrade of PV photovoltaic production forecasting tool in Slovenia. So the idea of VCBCC is to gather all needed information from synchro-grid devices, as well as renewable energy sources, and also some data from distribution companies in Slovenia and Croatia to improve power grid observability and to be able to implement advanced applications at ALS and HOPS National Control Center. One of the most advanced and challenging tasks was to implement a common voltage optimization tool. We call it voltage VAR scheduler. So the voltage control at the ALS and HOPS is done at the two levels. On the top level, we have voltage VAR scheduler application, which is designed providing both TSOs with optimal results for the regulating devices of both countries. It considered the cross-border limitation as well as the future hour grid conditions. It's very flexible and different objective function can be used for this purpose. The second level, it's so-called local voltage control done by distributed applications called VVC, which are located at both national control center as a consistent part of control system. So here you see the diagram. What VVC does, it collects the network and other models from both partners, LS and HOPS, merges the data, calculates the optimization, performs some validation, and the results are then forwarded to both control systems, where additional verification of the results is done, and then the results, if verified, are implemented as a set point to the individual regulating device. Second, let's say, chapter of the project was the implementation of operational data exchange platform. LS decided to utilize the ENSO-E solution called ECO-SP, which is very flexible, which provides secure, reliable, and easy to integrate platform. We all know that operational data exchange between the energy market partners is of crucial importance for reliable and secure operation of the grid. So it's very important to have tools which fulfill these requirements. Last but not least, just a few more words about photovoltaic production forecasting tool. It gets the measurement of the about 300 photovoltaic installations across Slovenia, plus weather forecast and weather measurement data, which uses for calculation of PV forecast at about 100 substations across the country. This is a very useful tool and helps operators in system balancing process. Just on time.
So thank you very much, Emil, Janko. Really interesting presentation. So we are going to keep increasing our knowledge in technologies developed by PCIs. So now is the turn of Akon, and it's Branislav and Thomas, if I'm not wrong, or I'm wrong. Yeah.
So first of all, let me apologize, but there's something with my voice since yesterday. I still hope that I can deliver this presentation without any problem. So this presentation is about the substation Borski Sveti Jur, that is a result of ACAN's project activity. To make this presentation a little bit more dynamic, let me start with showing a video from the construction period of this substation. There's a nice relaxing music, so it should be fine in combination with the current weather. So like colleagues before me, I wouldn't like to be repetitive, but it's, of course, when you build such a substation, you definitely achieve increased capacity to connect new customers, also to connect renewable sources, but time is scarce, so let me emphasize 3 main technological blocks I would like to talk about more. This substation is fully equipped with digital protection relays, all the way from high voltage down to medium voltage, where I would like to underline especially the medium voltage relays. So thanks to deployed medium voltage relays, we are capable to localize short circuit faults, so basically face-to-face faults, thanks to impedance method, so basically thanks to measurement of voltage and currents. The relay then evaluates the impedance of the short circuit, and the system of localization is based on primary reactance. So the substation, the relay especially, provides us with this information. This information is then sent to control room, and the operator of the medium voltage control room is able to visualize the place of the fault with accuracy for most of the faults plus minus 500 meters, which is really very convenient for the medium voltage grids. The other technologies I would like to talk are automatic switching sequences. So all the bays on the high voltage are equipped with bay control units, and the operator is able to start a sequence, for example, to change the operation of the substation from one bus to another without any intervention from his point of view. It's done automatically by the system, by the bay control units themselves. From the medium voltage perspective, especially from the transformer's neutral point, the substation is operated with arc suppression coils. Although this notion of arc suppression coils or resonant grounding, if you like so, is quite old, it's the very foundation of self-healing grids concept, and it definitely has to also accept the challenges that are nowadays impacted on this type of resonant grounding. And to achieve the very boundary condition, which is that the coil should be finely tuned with the grid's shunt capacitance, is done dynamically in real time thanks to the arc suppression coil regulators. And the last, but not the least, there are also impacts and benefits, but as I said, I don't want to be repetitive. Voltage regulators. Once again, it might sound what should be said about the voltage regulator. Well, we had several cases in our grids where the voltage was not regulated correctly, for example, because of an open phase fault on the high voltage grid, or a blown fuse in the measurement of the transformer, or just some kind of a short circuit in the secondary technology. So the new algorithm that is deployed in the voltage regulators is robust to this kind of situations. This algorithm also provides a corresponding, it's comparing the voltage that is measured on the medium voltage bus, and is also measuring all the three face-to-face voltages in real time. So basically, it's robust to this kind of situations that I have mentioned. So there's no overvoltage risk from this kind of cases we had in our grids. And this substation is a pilot substation from our point of perspective with this new algorithm. Okay, thanks a lot.
Branislav, please. Yeah, thank you.
Okay, so first thing first, let me introduce myself. My name is Branislav Vavruš. I come from EGD Czech Republic, and I'm a project manager of implementation of devices you can see on the screen. In the first place, let me explain you what is a power quality monitor, and in the following part I'll explain you the impacts of the technology. With the current situation and the energy transition, as you probably all in some way absorb, there is a really high, let's say, press to bring some observability and visibility to the medium and low voltage grids. From the historic perspective, the monitoring was, in the most cases, brought to high voltage levels, but on a medium voltage levels, especially in distribution substations, we didn't have the eyes, let's say, of our dispatching center operators, and of course we didn't have real time or real measured data from distribution substations. In order to respond to all these trends and requirements, it was like from our side to start deploying a unit that will bring the, like I mentioned before, observability to the medium and low voltage level. We started to pilot metering units that will enable us in the future real-time monitoring in distribution substations, especially on the low voltage side. We started to call this device universal monitor or power quality monitor. It is the same. What a power quality monitor exactly is. It's a device installed, as you can see on the right side of the screen, in a low voltage switchgear, and this device communicates to our either MDM system, which is a system directly connected to implemented by our smart metering, let's say, unit. It's in an MDM system. We actually gather all the data profiles measured by the power quality monitor. Also, data from power quality monitor are distributed to our SCADA system, so our operator can actually see what is going on in a distribution substation. What is the impact of this technology? It is crucial to understand one thing, and this thing is what is the decision basis of our technical experts with this technology. In a history, decision basis of our technicians was mostly relying on some estimated grid models that were using some grid documentations, planning guidelines, let's say some studies, or singular measurements that were put in the distribution substation just for a specific measurement, just for a limited amount of time. And based on this data, we had to decide, let's say, whether we connect or we do not connect some source or let's say photovoltaics or something similar. With this data, we actually have pretty good knowing of what is going on in the substation, and we can decide more precisely if we can connect or if we can accept the connection application, or we will just say that we can't connect our customer. This device is in this way, let's say, something like a game changer for our technicians, because we have real data, and we didn't have or we haven't had this data in a history. What about the impacts, or what about the other impacts of this technology? It is, like I mentioned before, it is more effective connection process. It is automated readings from power quality monitors. All data are available in a central storage, and there is no need to get there and get their data manually from the substation by our technicians. And the last thing what I want to mention is that it is an essential prerequisite for modern grid management. We call it active network management. This is something which is actually talked a lot in our company. We have to be prepared for the flexibility what is coming to us. There's going to be an aggregator. There's going to be a prosumer in our grid, and we have to know what is the power flow in a network. And this device, in combination with the smart meters, gives us the tool to actually handle these obstacles that are coming to us in the future. So that's from my side. Thank you.
So thank you very much to both of you. So we are going to continue with Danny Pingrid, and it's Mate and again Tomasz. I don't know which is the order.
So thank you very much. Let me introduce myself. My name is Mate Csőre. I'm the technical lead of Danny Pingrid Wave 2. And now I will talk about the OLTC transformers, which are installed also in the Wave 1 and will be installed also in the Wave 2. So the technology itself can be familiar to many of you because it is used since the early part of the 20th century. But the application to the medium voltage grid and to the medium voltage, low voltage connection point came only in the past 10-15 years. So I could say that in the lifetime of a DSO, it's a pretty young application in this manner. But why we do want to use the OLTC transformers here? Just a few numbers in Hungary that in our National Energy Plan 2030, we went for 7 gigawatts of inbuilt capacity, which was about the peak load of the country now. Now we have 10 gigawatt of connection requests in the system right now. So it's the renewable energy sources are increasing a lot in the past few years, and they are creating a huge challenge on low voltage, on medium voltage, and on high voltage too. And this asset mainly targets the medium voltage, low voltage part, where we are able to have a control point at this really critical point of the grid, and we are able to regulate the voltage, for example, on the secondary side, or if the voltage is too volatile on the medium voltage side, we are able to stay on the low voltage feeder with the voltages, or we can keep stable voltages on the low voltage feeder side. In this manner, we are able to get and accept more renewable generation on the medium voltage grid because the voltage can be much more volatile. We can have more increasement, for example, on the medium voltage side because the transformer itself can compensate it. The other thing I want to emphasize here is that the solution have three-phase measurements. So as it was mentioned in the previous speak, the observability of the grid will increase a lot, and this is the basis of the flexibility solution of the future. So we have to increase the observability, and we have to give this connection point and measuring point to this critical point of the grid here. The other and the third part, which I want to highlight here, is that the solution itself is capable to autonomous operation, so we don't have to interact it anyway. Maybe if we only want to change the parameter settings there. And in this way, we don't have much work to do with, and it helps our operation a lot during its lifetime. So what are the impacts and what are the benefits of the application itself? As I said, the efficiency in the day-to-day operation because of the remote access of it, it helps to gather data from the grid. It also supports standard communication of the grid, and this means that the interoperability of the OTSAT is ensured there. The security and the quality of the supply is also ensured there and enhanced because the voltage quality on the secondary side is improved a lot. And this enables us to plan in a more optimized way in the future. And when we gain more information of the grid, we are able to have more database decisions, for example, and more optimal decisions. So I think this was about the technical parts, and I just want to show a picture that how the transformer itself looks naked there without any oil. You can see that the windings are connected to the tap changer there, which is an on-load tap changer, and this means that when the transformer itself is energized, we can change the tap position and the number of the windings, and this is how as a regular transformer can be operated during, and the voltage can be changed during its operation. And thank you very much for it.
So my part is going to be about optical fiber network, which is one of the activities in Danube InGrid project. I would like to show you a video from a pilot installation of an optical attached cable to a medium voltage overhead line.
The world is changing significantly due to new technologies. Digitization is becoming part of everyday life and brings new opportunities to both society and to the people themselves. Without digitization, the world of energy would not be as it is today. Electricity distribution and transmission companies are currently introducing new smart grid technologies and building modern energy infrastructures. ZSD is utilizing the technique of wrapping optical cables around medium voltage overhead power lines in a pilot project implemented in southern Slovakia near the town of Rable as part of the Danube InGrid European Common Interest project with co-financing from the CEF Energy program. This is the first section in Slovakia using the optical cable wrapping technology on a 22 kilovolt overhead line phase conductor. The optical cable is designed to withstand environmental conditions while creating minimal additional load on the conductor. The installation does not require major modifications to the existing system, so the technology can be used for all pillar structures. A custom-designed device is used to wrap the cable. By installing this optical system, we have become one of the countries in which wrapping technology is used on medium voltage line conductors in the field of network digitization. It is important to think about the future and be prepared for new challenges.
96 fiber is up there with the maximum size cable, and a lot of companies and countries have regretted not installing 96 in their previous installations. So it's good to see in Slovakia they have gone to the maximum cable with the maximum capacity with thought to the future. It is what is required in the future.
So there are several ways how to install optical fiber in the grid. We can look at it from the voltage level. So basically on the medium voltage we use ADSS, which is all dielectric self-supporting cable, or we go underground with the optical cables, or as it was shown in the video from our pilot installation near Rable, we can do it like an opaque optical attached cable. From the high voltage perspective, the most widely used is OPGW, optical ground wire, although we can't see it. It's located in the uppermost wire, which is grounded. But there are also some short sections installed as ADSS, because sometimes we go from a high voltage lattice steel tower with optics to ground. That's why we also use this kind of technology in the high voltage grid. Altogether, 320 kilometers of optics in ZSD. So what are the impacts or benefits? I think we're living in an era where the whole society experiences transition, and our energy sector is definitely not an exception, and digitization is definitely one of the transitions. By building optics, you basically enhance or increase the redundancy of the system, either between the substations themselves or between substation and the SCADA system. Optics are very robust, fast, and reliable communication channel. Once you have this kind of network built or installed, you can use it for a direct connection of future remotely controlled smart switches or smart transformer stations to optics. And definitely you can pilot and try the concept of decentralized self-healing grids, for which optics are the very boundary condition. Thanks. Maybe if I have a little more time, just a few pictures from installations. So on the left, it's the ADSS that was mentioned, all dielectric self-supporting cable on a concrete pillar in the middle on a lattice steel tower, also with termination box. And on the right side, there is the optical fiber that is directly attached to the medium voltage wire or medium voltage conductor. And there's a pole-mounted switch that is connected directly to the optical fiber network. Thank you.
So with this presentation, we finish the top of the iceberg of the technologies of the PCIs, because we can be talking here for years and years. So we move to the Horizon projects. So we can start with Manuel from Crossbow. Please, if you can join here. Thank you.
So first of all, thanks the organizer for inviting us to this PCI event. I have the chance to start with the Horizon 2020 projects presentation, and be, I think, the first speaker not coming from a system operator. So let me introduce myself briefly. I'm Manuel Serrano. I'm coming from a company in Spain, Etrel Research and Development. I'm here with my colleague Bojan from another company, Elpros in Slovenia. We are technology providers, and within the project of Crossbow, we were the ones developing the technology that later on was deployed and tested in the field. Very briefly, just to honor the consortium, I will not waste the time we have on this. Just to let you know that the effort in the project was supported by nearly 30 partners, 30 institutions, universities, industry, and 9 system operators. We work for a little bit more than 4 years in 9 different solutions. We will only show you today a couple of them, okay? And it is a big project in the context of research. 22 million euros maybe not see too much in front of the budgets that are managed by the PCI project, but in terms of H2020 and research, is one of the biggest projects you can find. I give the floor now to Bojan that will show you one of the first technology we have selected to share with you today.
Thank you. Okay, so my name is Bojan Markovec. I'm from company Elpros. So we was involved in this Crossbow project. So Crossbow project, one part of the project was also the VAMAS project, which include the data from different TSOs. So the data was based on the PMU devices and the SCADA system. So one of the modules which we developed inside was also the over frequency real-time dynamic settings for the generators. So the main issue was the network code, which has regulation for the generators that has also the limited frequency sensitive mode. This was the base of the over frequency protection development. So the main problem is that majority of the generators is quite old and they doesn't have this option to control the generators on this way. Such example actually was also in this crossbow project. The Serbian TSO, Elektromreža Serbia, was involved in this project, and they suggest the solution which is not based on the generators with the controllers on the generators, but the centralized system. So the network code has also option for alternative solution, and in this case, the alternative solution was proposed. So a solution was based on the VAMAS data, so data from the PMUs and from the SCADA system. And then based on that data was developed the algorithm which has priority list for the generators, and regarding to the situation with the over frequency, from one central point activate the generator shading. The system itself was developed for the automatic control. So that means that it's capable to send the command directly to the power plant and disconnect the generators. So it used the standard protocols like ESC 8075, 104, or TASE protocol. And from the point of the implementation, this is the case how to get good benefits from the data without additional investment into the hardware. So practically, from the point of the investment, the technical solution was achieved without any additional upgrade of the hardware, which would have involved a lot of additional cost and also the time to implement and upgrade the generators. So in this picture here, you can see the concept. So here on the left side, you can see the central VAMAS system, which collect the data from the TSOs, so the SCADA data, PMU data, and other data which is available. So on the right side, you can see the table with the generators. So it was inside around 100 generators, which was configured by the priority list. And also additional requirements is that each generator must have the minimal generation that is included into the scheme for the control of the frequency, and then everything goes automatically. So in this stage, which was implemented in the project, this is now actually the guide for the operator in the control room. So we give him the signal what to disconnect, and then the operator can disconnect that generation inside the system. But technically, it's completely autonomous. It can operate in the automatic mode. So on the bottom, you can see some measurement. So on the top is the frequency. This is for 1 week situation. And on the bottom, you can see when was for the selected generators, the situation at which, so the frequency at which was that generator selected for the automatic disconnection in case that frequency will go over the limit. So in the frequency, our frequency regulation with such concept was in this case specified on 50.2 Hertz. So that's all from my side. Thank you.
Thanks, Bojan. And then the second technology solution we have selected to share with you today is the Cross-Border Control Center for Renewables that was actually deployed and tested in Romania, Greece, and Bosnia and Herzegovina and Croatia. It basically provides a solution that can be instantiated and used by different partners in different places. So it's virtual, so to say, though it is tangible. I mean, it provides a user interface to control all the portfolio of renewable production units, forecasting of production, forecasting of demand, there are some of these features that are actually not provided by the Crossbow project, but by our broader project Trinity. Crossbow completed its activities late April this year, and we have a continuation project that is providing some of these features, digital twin integration, use of blockchain for the management of guarantee of origin, etc. It is fully integrated with WAMA, so basically one of the things we tested was the capability to actually take the congestion forecast detected by the system operators with WAMAs, analyze it from a point of view of sensitive, provide a solution for correction, and then make the entire implementation until the curtailment in the SCADA system of in this case of a wind plant. From the point of view of visualization, everything is integrated with. I mean, I'm just showing the graphical user interface part, but this is relying on digital twin technology. So the entire RES units are integrated and simulated, not just for visualization of real-time data, but also for the analysis of forecasts. That will be it. I'm in time? Good.
So we are going to continue with Horizon projects. Please, Samuel from FlexiGrid.
Well, first of all, thank you for the invitation to this exciting event. I am Samuel Borroy. I am the director of the electrical systems area of CIRCE. We are a technology center, and we work in collaboration with companies for the electric energy sector in order to provide innovative technology solutions and also engineering and advanced consultory services as I have said, in the energy sector. We are very active in Horizon projects, such as FlexiGrid project, especially in smart grids related projects, such as this one, in which we are the project coordinator. We have on board a consortium composed by DSOs, big companies, technology providers, technology centers, universities, aggregators, associations. And the general objective of the project is to develop technology solutions with the aim of increase the distribution networks, monitoring and automation capabilities, with the final objective to increase the flexibility of the network, the automation of the network, the observability of the network, and at the end to increase the hosting capacity, flexibility and hosting capacity of distributed generation into the distribution networks. So with this objective, we are developing in the project up to 9 technology solutions. Today we are going to select 2 of them, which I think that are quite representative of the objectives of the project. So the first one is what we call the secondary substation of the future, or let's say a smart secondary substation, which is a solution in which we integrate different developments coming from different partners of the project. Mainly, we are integrating in this secondary substation a smart transformer, which on-load tap changer capabilities, which make the transformer able to regulate the voltage levels in medium and in low voltage networks, with the objective to cope with the fluctuations in the voltage which can be generated by the connection of different type of loads, and especially distributed generation in the low voltage networks. So it allows to regulate the voltage levels automatically without the need to stop the service and change manually the setting of the tap of the transformer. We also include in this solution an advanced low voltage board, and also new functionality for the medium voltage remote terminal unit, including web services. So this RTU advanced serves as a gateway for a fast integration of all the communication devices included in the secondary substations and to integrate with the DSO's SCADA and control center based on IEC 104 protocol. We also integrate in this smart secondary substation what we call the energy box, which is a specific development of the project, which is a smart concentrator and hub for multi-protocol communications, and also integrates computation capability to perform edge computing functionalities. This solution is being developed. We have just finished the development of the solution. We are facing the last year of the project, so we are now in the demonstration phase. We are installing this advanced secondary substation in selected points in the distribution network in the north of Spain, one of the partners of the consortium, EDP Redes, former Viesgo Distribución. So the main impacts of this technology, on the one hand, this smart distribution transformer can help to increase the hosting capacity of distributed generation in the low voltage network, thanks to this ability to regulate voltage levels without the need for increase the physical infrastructure of the network. The low voltage board provide advanced low voltage supervision systems. It includes the advanced supervision of the different feeders of the low voltage network, including each phase of the feeder, and also the capability to measure neutral currents and to communicate with a new generation of smart sorry, I have forgot the name of smart meters, sorry. Smart meters which are being developed also within the project with feeder mapping capabilities, so that they can be integrated in this holistic supervision system and monitoring to facilitate the observability of the low voltage network for the DSO. Of course, having all the system communication integrated can reduce travel times and need of physical field works, so it reduces the need for this type of resources. And the energy box allows the integration of all these elements with another controllable elements which can be connected downwards in the low voltage side of the distribution network, allowing the implementation of monitoring and control architecture for the integration in the distribution network of elements such as prosumer, distributed generators, and other type of new actors. A little bit more graphic vision of this development. Here we can see in the left side the medium voltage side of the smart secondary substation with the medium voltage cabinets, the different control and monitoring devices connected with the RTU and with the communication with the DSO, SCADA, and control system control centers, and as well the communication and the integration in the right side with the low voltage board, the smart transformer that I've mentioned, and in parallel with of this, the EV energy box, which can, as I have mentioned, connect with downwards elements such as customers, prosumers, distributed generators, microgrids, and another type of possible flexibility actors which can be interconnected with the smart substation. So the second technology that we are also developing is a prototype which includes hardware and especially software developments, which is a fault locator for medium voltage feeders, which is based in time domain reflectometry. The system injects low voltage, high frequency pulse into the distribution network. It is injecting regularly, and when there is a fault, the algorithm compares the response of the system before and after the fault, and when a machine learning algorithm it estimates the distance of the faulted point from the injection point of this algorithm. So we have developed the prototype and the algorithm, and now we have just installed in a specific section, also in the network, distribution network of the north of Spain, and we are in testing phase to calibrate the machine learning algorithm. So the impact of this development, well, the improvement of fault location obviously enhance the process of supply restoring in medium voltage distribution network, which is one of the objectives of smart grids, and therefore reducing the outage time due to faults, which leads to direct impact on improvement of KPIs such as KID and SAID. It can be a valuable input for the automation of fault location processes if we think in self-healing algorithms, and therefore reducing also the indicators that I have said, and also the need to field workforce for the location and the restoring of the supply after a fault occurs. And also a relevant characteristic of the system is that it is independently from the magnitude of the fault current, so it is independent from the neutral system of the distribution network. It can work for grounded systems and also for ungrounded systems, as is the case of the distribution network, which is going to be tested in FlexiGrid project. Also, the presence of distributed generation along the medium voltage feeder should not affect the behavior of this fault locator, which is another advantage considering the new scenarios that we are analyzing in these projects. So again, graphically, a little bit scheme of the system. We have the fault locator, which has connection with a conventional overcurrent relay of medium voltage lines, and the capacitor, which is the coupling of the injection point with the medium voltage line. So when a fault occurs, the protection relay sends a signal to our locator, so the locator knows that there is a fault and compares the previous response of the system to the injected point with the pulse that it injects once that we know that there is a fault. So the comparison of these signals using machine learning algorithms allows the result of the estimation of the distance to the fault, and then the next point is to send this data to the DSO in order to take part of the fault location and system restoration process. So, thank you very much.
So now is the time of Osmos. We continue with Horizon projects. So, sorry, I forget the name of the project presenter. So, Miran, please. Thank you very much. Floor is yours.
Okay. Hello from my side. I come from the other side of the power line, from HSE, from Holding Slovenske elektrarne, which is one of the biggest Slovenian power producer. And I would like to say hello on behalf of HSE and all the partners of the Osmos project. Osmos project was composed from 33 partners coming from 9 countries. And basically the topic that we have developed our technologies, thoughts, and our products was about flexibility. So how to increase flexibility with the devices that currently exist and how to use the devices innovatively. So the results were quite interesting, and since we are very limited on time, I will present just the 2 of the technologies or 2 of the innovations that come from the Osmos project. So first is an innovative hybrid flexibility device. This is basically a device that is composed from capacitors, batteries, and a STATCOM. The device is put into a 20-feet container, so this container can be moved or placed basically anywhere in the transmission or the distribution grid. And what does this device do? It can perform 3 levels of control. On the primary level, it can add to grid stability. On the secondary level, it can improve frequency and voltage control. And on the tertiary level, it can optimize the flexibility devices. So this means the flexibility potential of the device itself. So how does it work? It measures all the frequency parameters, all the voltage parameters, and then it tries based on the optimization criteria function. It optimizes the device in such a way that it minimizes the device's use, it minimizes the deviation from the state of charge capacity, and it minimizes also the power fluctuations. One of the innovations or one of the advantages of this device is that it has very small losses. This is due to the operation voltage of the battery. For this special operation, the voltage of the battery was increased to, like you can see there, to 1,260 volts. But in the laboratory test, it reached also 1,500 volts. So it's a really high voltage for battery operation, but the losses were reduced. So what are the impacts of the technologies? This is a new FACT device that can be used. It's also on the how to say production or on the factory level. So it is tested. Basically, it's just one step to be available for commercial use. It's comprised of supercapacitors, batteries, and a multi-level STATCOM. It can provide multiple grid services, and it's used for optimal coordination of hybrid energy storage to provide different flexibility services. Like I said, one of the main properties or characteristics is high voltage of the battery, and the next steps is just to put it on the market. So I was instructed to very briefly describe the device, so if you have any other questions or comments, you can find me after the event and you can ask about this technology, or I can point you to the web page of the project. So here is also a picture, 20 each container and so on. This is a scheme of the container, so you can see the DC-DC converter, outputs, power racks, and so on. So the second device, or the second innovation from the SMOS project, is a concept, a management that is made of a SCADA system, of industrial loads, of the grid flexibility, and of the demand side management. So basically, the idea of the partners that were involved into this device or solution was how to innovatively use wind parks, demand side management, flexibility devices, and also how to use the dynamic line rating. You heard about dynamic line rating at the beginning, so I think that it doesn't make sense to lose any much time on that. So what is innovative? Innovative is that the wind parks were used also for voltage control. So yes, one of the main findings of this was that yes, all the wind turbines should be equipped out of the box with voltage control. So in this way, you can extract more from the wind farms. The other invention or outcome of this part of the project was a finding for the industrial demand response that yes, there is a lot of flexibility in the industrial demand side responses. There are a lot of devices, a lot of flexibility, a lot of potential, but the production line of the industry is optimized for maximize the production of the products. So if you will decrease the demand, so you will decrease the power of such production line, you will not produce at the end products. So basically, unless the energy in terms of euros comes into the objective function of the owners of the production lines in the factories, there is very little demand side response that can be used from industrial loads. And the third main finding was about the dynamic line rating. It's written down there. There were two approaches for dynamic line rating. One was based on the weather forecast, and one was based on the radio sensors. The result was that the dynamic line rating based on the radio sensors. So you put a lot of sensors on the power line, and then you collect the data, and then you send it to the SCADA. It's much more correct than just to rely on weather parameters. So in this case, if you use the parameters on the line, not just based on the wind and solar and temperature, you can better use, or you can exploit more from that power line. And upon all of this, there was a SCADA that was a system that was built especially for this purpose, so it can combine all the data from these three innovative and new solutions, and it can suggest to the operator which actions can be triggered. So can you get some flexibility from the demand side response? Can you get some voltage control from the wind farms and so on? And another picture. There are many elements here, so this is a more high-level picture for promotional events like this. So any questions? I think I was very well in time.
Yeah.
Okay. Okay. You're welcome.
So, okay, we go with our last Horizon 20 project. Thank you very much, Stefan. The floor is yours.
Nice, thanks. So, welcome everybody. My name is Stefan Groß. I'm the project manager of the OneNet project, and I'm representing the founder of a society from Germany. If I see this correctly, I have 4 minutes, right? Okay, I will hurry. So, the OneNet project is quite an ambitious project, and all the numbers mentioned in the relation to Horizon project I can top. In general, what we want to achieve is to create a fully replicable and scalable architecture, meaning an IT architecture, which supports a large variety of use cases, usually cross-border. We want to think the European energy system as one system, following the European approach, and we want to integrate a variety of market schemas. And of course, we want to integrate as much participants and stakeholders as possible. Coming to the pure numbers of the project, we are in total right now 71 project partners. We are actually integrating 2 new ones. We are spread all over Europe in 21 countries. We are including the largest associations of the grid operators, NSOE and EDSO. And we have 4 international demonstration clusters connecting 15 countries in total. We have 3 more main pillars which we're working on. One is the common market design for Europe, then the IT architecture, which will allow us to enable use cases on a cross-border level. And then we want to verify all our approaches, of course, in this cross-border international use demonstration clusters. We hope, or we think, we are making another step in the direction of a harmonized European energy market design, developing the standard products for system services in a DSO, TSO consumer value chain. We are following the IT architecture, which we didn't develop completely in our project, of course. It's a long-term process in a series of Horizon projects, which we are largely based on. For example, Coordinate and Interface, which were our pre-accessor projects in the same call. And of course, everything under the integration of TSO and TSO cooperation, enabling a common communication channel, and which comes then with semantics and syntax and the data models and so on and so on. And presenting, I could speak a long time about OneNet, and I will not. So I will just present you the high-level overview of the IT architecture, because it's the most concrete part of a technology developed. We have a lot of other things which I'm quite proud of in OneNet, but let's keep it to this picture, which is already quite complex by itself. Basically, what you can see here is the approach of now we are mostly calling this European energy data spaces, where you potentially know there's a series of projects just started following a similar approach. But on the bottom line, or on the bottom, what you can see here is that we have a wide variety of use cases or data sources, stakeholders, which are all partially integrated, mostly on a national level, in their own platform setups. This includes, of course, markets, their own data models, their own communication infrastructure. And if you want to aggregate this information for higher level purposes in a cross-border level, we have to make them somehow capable to speak to each other. And here's where the OneNet architecture starts. It's everything orange part and going up then, where we have our OneNet connector, which enables this communication exchange following the NGSI API, which is following the 5-air and data space initiative approaches, going into the file context broker and then in the IT infrastructure, providing all the basic functionalities for such platforms nowadays, like access management, semantic checking of the data, and so on and so on, enabling our higher level use cases for cross-border trading as part of the northern demonstration, security value chain or security exchange, IT security information exchange in the southern demonstration, or more DSO level use cases in the eastern demonstration cluster. And I'm more than willing to answer all the more precise questions afterwards with a coffee. Considering the timeline, I think I will stop here, and I'm inviting you to come to speak to me afterwards. And yeah, that's all from my side. Should I?
Yeah. Please, all the speakers that were participating now in the presentation, if you can join us in the stage, please. So thank you, everybody. We heard really interesting presentations, and thanks for keeping it short. I know that can be for hours, but well, we are a bit delayed, and I think we need to be on time since we have here Katerina Sikov-Magni, which is the director of the energy transition, and she's going to make the conclusions in the end. So we better conclude before. So well, we have seen, as I said, some interesting technologies. And I would like to hear from you now that... Okay, thank you, Mira. Yeah. I think that you were there, but you're fine there. Because I think that we lost in between Thomas. You're okay there. So what I was saying is that we saw really interesting technologies. And one of the ideas here, we started with the pillar of understanding which are the PCIs, how to get the status, and which are the tricky parts of the implementation. And now we wanted to see which are the coincidences between technologies, so innovative technologies that they are being developed in other programs, as for instance Horizon, and the technologies that they are being developed also in the PCIs. So I'm going to skip the easy question that I made in the exchanges that we have in the beginning, if you heard about each other, because in the beginning I was surprised that sometimes was not a yes, or was some of the players were not known one to the other. Now I think after all these presentations and so on, we know each other quite well, or at least much better. That was one of the ideas of this event, was creating a collective knowledge on smart grid projects, European projects. So now that we can say that we know each other, I would ask, and I will start with the PCI representatives. So Janko, you will be the first one, since you're playing at home. Do you see potential in the type of technologies that you have seen and what you know of the Horizon projects that we have been exchanging information on? Do you see potential of PCI projects implementing this type of technologies?
Yes, I see, of course. I understand that...
I think you're off. You need to...
I understand that Horizon projects are more, let's say, research and development projects, and yet if you want to implement technologies in a PCI project, which are investment projects, then these technologies should reach certain technology readiness level. And this is the main problem, to my understanding. Because the operator or the end user expects high-level quality, results, availability, reliability of the systems.
Thank you, Janko. Do you want to mention any specific technology that you have seen?
For example, we have been working on dynamic line rating like Sumo on the Synchro grid, and as Miran explained, on the Osmos. And I think this is one case how this particular technology may be used.
Okay, thank you. Mate, Danny Pingrid, please, same question.
Yes, I think we can totally adapt most of the technologies that was presented, and they will be adapted in the future. For example, the flexibility market concept and the flexibility data platform is a thing that we have to adapt in a very few years from OneNet. But the first step is that we have to have the adequate measurements and the adequate readiness of the network to adapt this whole concept and adapt good flexibility solutions there. So this is one thing, and from the other H2020 projects, I think we had the OLTC transformers too, where a higher level concept, when we, for example, installed all the OLTC transformers in Ingrid, we could totally accept a higher level coordination for these transformers or the pole-mounted switches, which will also be a next step, and our SCADA will be ready for this. So I think many applications in the near future can be adapted and can be part of the future of the PC or future PCIs there.
Thank you, Mate. Branislav, same question.
Well, I totally agree with the colleagues. It's crucial to understand that. I totally agree with the colleagues that mentioned the technologies presented by Horizon colleagues. They need to reach certain level of maturity, and DSOs are, by its natural, companies that don't want to invest in something that isn't checked, that isn't reliable. So it is crucial to really have some reasoning behind these technologies presented today, and I see a lot of potential in these technologies.
Okay, thank you. Actually, I think that the type of Horizon projects that were presented, I think they are high tier in general, but I think that your comment is totally valid, of course, and you're fully right saying that. But then let's put the same question to the Horizon colleagues. So we can start. Let's start from that side. Samuel, please.
Well, I think that definitely. I think that they are compatible. The technologies are being developed in Horizon project with the challenges that are being addressed by PCI projects. We have seen today some solutions which are aligned with the challenges. We are talking about the flexibility of distribution networks, protection of the networks, the automation of network, integration of renewable energies, and the role of the user or the prosumer. So, well, I think that we should find the possibility to collaborate or to find synergies between Horizon solutions and PCI projects implementation.
So then, basically, for you, one of the barriers can be the alignment of the objectives, of the challenges between what the PCIs need and what you are producing right now.
Yes, I don't know if it's a barrier or I don't know. Maybe make some direct connections between the description of the Horizon calls and the challenges covered by the PCI projects.
So we continue with the next one, same question. So do you foresee potential and main barriers for you?
Yes, of course. I think otherwise there wouldn't be a point in Horizon projects. But I think we are further from a technical readiness level. You're right. Most of the Horizon projects nowadays have a very high technical readiness level, which they have to achieve. And a lot of solutions are out there. And then there are a lot of problems coming with them. Most of the Horizon projects are quite limited in time. We are developing a solution for a concrete problem. saying, okay, here that's a system which would work, or a market adjustment, or a new product for system operation. And it is difficult to communicate this, especially to grid operators, saying that's a solution for your problem. You could apply this, because that's not their normal business. What they're doing, they are putting new substations and cables in the ground. Mm-hmm. And so it's sometimes difficult to convince them from our ideas or our solutions which we are producing. There are some examples where it worked, but yeah, overall I think we can be more positive, saying, okay, their solution and grid operator, we have to communicate this better to PCI projects, for example, to bring this into the field. Mm-hmm. I think that would be a good approach.
Okay, so we continue. I want to ask all HORIZON colleagues also. So Manuel, please.
Thank you. Okay, so I will not hide behind the high TRLs. I fully acknowledge the point from our colleagues coming from the PCIs, because indeed, HORIZON projects, we mainly deal with research, okay? And actually our funding is to cover the risk of the innovative solutions and the new paths that we try to explore. However, it's absolutely true that the representatives today, we are the projects that, so-called demonstrated-oriented projects, which basically means that all of us, we incorporate system operators in our consortiums, try to find their needs from the beginning, so the innovations is clearly driven by the needs of the end user, which is, I would say, a good practice in general for a good business, okay? But in particular, in the kind of solutions we provide, is the only way, if we want, after the end of the project, to cover this gap between our results, which are fully deployed in the field, verified and tested, okay, but maybe still not certified, so TRL 9, and for sure have not, in most of the cases, demonstrated their capability in larger scale, okay, because we are not an investment projects. We don't have this kind of assets and capability to demonstrate the solutions we have, country level, region level. So the kind of things we do, we provide a new path of solutions, and we test it in real life, okay? But it's true that there's this gap that I think that if we are capable of creating some bridges with PCIs from the beginning, this is something that would facilitate the transfer of technology and know-how from what we are doing in HORIZON to PCIs.
Thank you. Miran?
Okay, maybe just an observation to conclude this round. Our project was also, in our project there were also many TSOs. It was Slovenian, Italian, French and Spain TSO. And it could be seen and also felt that there are TSO there and they want to have results. They want to have something that is applicable. So the demonstration where there was a large impact of TSO, or where the role of the TSO was big enough, there came really applicable solution. That was like, for example, the dynamic line rating. Terna was really involved in that project. So yes, basically the product was almost there and it can be used by Terna. So yes, HORIZON typically is really about research and so on, but of course there can be done some project, and I think the outcome of the HORIZON project is also defined by the consortium. So maybe if you have just research institutions, then you will have, of course, a lower technical readiness level. But if you include companies that come from the market, or TSOs like, then it's a highest probability that you will have at the end something that's it's applicable, or that you can put it on the market, like the 2050 battery container. Mm-hmm. Thank you.
Actually, I think that you said a good point. Also, the structure of the projects of HORIZON is based on consortiums, and sometimes might be that this gap is also generated because of the rights to exploit the different products that you have. I open it to whoever wants to answer.
If I may, yeah, indeed, this is, I would say, one of the barriers for the marketing of the solutions sometimes. It's a barrier that can be overcome easily by design of the project, but it is true that by the end of the day, it's common to our projects that the research is made by several partners, so the know-how is being pushed from different sides, and the new ideas, you need to be careful at the beginning when designing the projects to define who is going to be the owner of the idea, the owner of the solution, to later on not having problems when transferring this to the market. I think this is something that all of us are already doing. I mean, it's business as usual for most of us, but it's true that it's something that has to be considered. Otherwise, you end up having a good results that is ending in a good paper, but without any further possibility to go to market.
Okay, thank you. So, well, I am understanding that basically there is a potential for sure for cooperation from either PCIs or HORIZON projects. Otherwise, you wouldn't be here because I couldn't do the next question, which is basically how do you foresee this cooperation? So up to now, before we try to introduce to each other, you heard about yourself and other projects and so on, but maybe not to the level of detail that you have right now. So how would you kind of trigger a better cooperation between both sectors or both sides of the projects? Janko, we are going to start from you.
I think that the key word is exchange of information.
Mm-hmm.
I think that many results are available and potentially useful for end users, for decision makers, but they need to be circled. They need to be put in a flow. Mm-hmm. And meetings like this one today and similar are, to my opinion, a great way to achieve this. Maybe one, as an idea, is that there is a catalog that is maintained by, I don't know, CINEA, mm-hmm. that collects information from different projects, describing the key features of technologies that this knowledge is concentrated in one document.
Okay, interesting. Mate, please.
Maybe I would take it from the other side, but I also think that these opportunities and forums are quite good place to share information, but not only about the results that we can see and the developments that we can see, but rather the difficulties during the implementation. And all of the speaks were very good, but I think the main discussions were during, for example, lunch, when we heard that what the project difficulties really were during the implementation. And I think that is why it's important to have discussions like this and forums like this or conferences like this, because this is where we really know or get to know those difficulties and those problems that we don't want to repeat, because I can say for sure that we can repeat these problems, but it's better not to.
So we follow the same path, but maybe I will extend the question. So, because I guess that the answer is going to be more or less the same with your nuances. Please go ahead, now you say them, but also say which would be the best point for you, for instance, to have this type of meetings, if that's your idea.
Well, I can say that you need to bring technicians to the discussions. I think sessions like this, it's especially for me, it was amazing because I could see what's happening in the HORIZON project, and when I come to my company, I can talk to the engineer, to the technicians, and we can have a discussions. Guys, have you heard about it? Have you given a thought about this concept? And it is really crucial to bring a guy guys with the deep knowledge about the technology and the solutions, and they are the only ones who can like fully understand the potential, and that is crucial, I think.
So we are going to continue this side. Same question, Miriam, please.
Yeah, I was just thinking, and how do you know what does your neighbor do? Mm-hmm. You knock the door, you bring a beer, and you talk. Mm-hmm. So yes, first thing are the events, because you mix the people, people talk, and they exchange ideas, they present their ideas, and they exchange opinions, experiences, and ideas. So events like this always. Then second thing, maybe, how do you know what's happening on the market? Basically, you would need a person in your company or institution that would always be on track with what is happening. What are the open calls? What are the closed calls? Which companies are involved? Maybe this would be another way. And an alternative or another option would be you always put the TSO in the middle. So you have TSO involved both in Horizon project and both in PCI project. So you have an entity that is always in center and knows both what is happening in both worlds, and they can combine.
But if I made that happen to you with Osmos and Synchro, and it seems that the communication, even good, was not 100% flowing, correct?
Correct, yes, I agree. Well, the reason for this was that the TSOs involved in Osmos were not involved in the same fields as they were involved in PCI. Mm-hmm. So maybe this was something that we can build on. So even if you are involved in a Horizon project and you're also involved in a PCI project, it can happen that you are not involved in the same field. Because, I can say, for the example, for LS, we were involved in a near to real-time market. Mm-hmm. But on the PCI level, LS was involved in another field. So how to combine both of these words is difficult if you have a limited amount of resources. So, yeah, basically you need to have some persons that are involved, so they have a good overview, and they manage with the ideas and.
Correct, understood. And it's also a matter then probably of design, no? Which is the concept that when you start the project, yeah, either Horizon or TSO. So we continue that direction. Samuel, please, in short, but events is clear, that is something interesting. But other new ideas?
Yeah, well, I think that...
One second. Sorry, because I think that we have up to 10, because I swap with Elena. Elena will present the HDA's presentation. Is okay, Katerina, or we need to hurry up? Okay, then we'll stop here and we discuss over a coffee. That's okay with you? Okay, so thank you very much. Sorry for being a rush. We'll have time now with the coffee. I will be happy to hear all your ideas. And let's try to make it better. Please, Katerina, the floor is yours. Well, I will applaud them.
Many thanks, Eduardo. Good afternoon, ladies and gentlemen, and sorry for causing all this hassle from my side. I mean, it's all because of the Energy Council being organized extraordinarily tomorrow at very short notice, and they are discussing the crisis measures on electricity prices, so I had to go back tonight, which of course made my whole program very different. But you know, I did not take the easy route and cancel everything. I still really wanted to be here today. So, and that's why you have been now pushed for stopping the previous panel discussion too rapidly. So, first of all, many thanks to UROS and the whole LS team for organizing this summit very well and in a very good, timely moment. So events like this are precisely what we need. We need designing good projects and implementing them as an objective, but of course we shouldn't end there. And as we could hear in the panel discussion, we need to talk more to each other, share our experiences, lessons learned, best practices, perhaps even bad practices, and the challenges that we have experienced and how we overcame them. Because in innovative, technologically novel projects, there are always challenges.
It's okay.
So this PCI summit on smart grids aimed at doing exactly this. So creating a platform for open discussion where you could learn directly from real projects that are being implemented on the ground as we speak, how they came together, how they engage with stakeholders, how they applied technology, how they implemented, and which are the synergies then that are there with the innovative technological solutions. Even for us, and perhaps even more so for us in the Commission and in SINEA, it is really valuable to hear firsthand and in detail about all these projects, about the good ones, but also when things don't work. And I think in technological development, it is obvious that not every technology, not every technological project succeeds. I mean, that's the essence of innovation, a lot of trial and error. So I really want to thank all you, project promoters, panelists, for sharing your views today with all of us. So we have had a lot of good tips that might be then useful to consider when thinking of a possible PCI project in the future. For instance, you could probably benefit from engaging the executive management and board of your companies to this work. I mean, it's the same for us. We need the political backing from our commissioner and commission president for new ideas. This is an effort at the beginning, but it certainly pays off. You may need to change and streamline certain internal company processes. You may need some internal culture changes within the company. Strong project management and avoiding delays become very important here. And perhaps make sure you understand the EU procurement rules well in advance, well before going into procurement for equipment or services or what they may be, because the EU procurement rules may sometimes differ from the national ones, and then there is a problem. And you can always then reach to existing promoters of PCIs. They can certainly, and I'm sure they are very keen to exchange with you and help you overcome whatever hurdles there might be. And my colleagues in SINEA are always, of course, also at your disposal. Maybe there are also some disadvantages, and not everything is an advantage. So we've heard some mixed feelings during the day on permitting, for instance. Even if from the Commission side we have done a lot on permitting, but still seems to be issues maybe more on the implementation side. And we look forward to discussing more with all the promoters to see how we can make sure that the implementation of permitting is really streamlined as it is supposed to be. We do have a platform of national competent authorities for the PCIs that can deal with the concrete challenges here. And we will put also our teams in working with those platforms. So despite these complexities, the benefits of working together and of smart grids are enormous. And of the summit today, so the political visibility, public acceptance, enhanced quality and improvement of internal practices, and when we get to there also in terms of permitting streamlining. CEF funding, if you're a PCI or a HORIZON project, then you get HORIZON, not CEF, and a lot of knowledge gain from partnering with international colleagues. So I'm very happy to hear that it is even very rewarding personally for many of you to work on projects that help your country in the next 30 to 40 years. I remember when we brought the type of project of smart grids into the Trans-European Networks Regulation in 2013, when the previous 10E entered into force, nobody knew what smart grids would be. They were like a fancy concept. TSOs were telling us that our grids are already very smart, so what are you talking about? But now, with you, with your experience, we know what smart grids can be at their best. And there is still a lot of innovation in terms of different types of smart grids in the future. So you have made the smart grids concept out of this fantasy type of a world into a concrete with a meaning and a very useful meaning. So we have heard from the promoters these presentations on these innovative technologies that are being implemented and being integrated in the electricity grid. We have seen a clear alignment between the smart technologies developed in both programs and the potential to integrate the new concepts and technologies that come from Horizon into the PCI process. And as in the previous panel, I think we could hear from all the panelists, communication and cooperation between programs, between people, between countries is extremely important and can be improved further, starting from increasing the knowledge sharing. And the cooperation should certainly generate a more efficient and innovative development of the European grid. We need it more than ever, given the increasing amount of variability in the grid with the renewables, with more and more electric vehicles in the grid, and now in the awful context of the war, all the smartness, efficiency that we can get from the grids, be they transmission or distribution, is essential. So this event today is a clear example of what we can do, what we should do, and what we should do more. So we certainly encourage then other projects of common interest to repeat this initiative, and we do look forward to future summits. So meaning that we hope this is not the first and the last PCI Smart Grids Summit, but there will be more to come on a regular basis. Because your work is extremely important, not only for the grids in your country, but to the Europe as a whole, in order to have the integrated grid we need that will then bring cost savings, that will bring efficiency, and that will bring decarbonization, electrification, etc., etc. So many thanks to you for your hard work. Many thanks for making the concepts a reality. And we will then look forward to further cooperation with you, further new smart grids PCIs, and I look forward to seeing you in the next summit. Many thanks.
So, last but not least, I'm asking Ms. Elena Genaro Tejada to present us new operational digital platforms call that will be opened in the fall.
Hello, good afternoon. I'm sorry, I'm the last one. Thank you very much, first of all, to the organizers for having invited me, particularly the colleagues in CEF energy sector, and also Elis, of course. My name is Elena Genaro, and I work at HADEA, the Health and Digital Executive Agency in Brussels. I will say a few words of what HADEA is doing. HADEA is a newly created executive agency during the pandemic, and it covers different sectors: health, food safety, space, industry, and digital. HADEA implements programs during this programming period, 21 to 27, for a total of 20 billion euro. I will skip maybe the health and go to the digital part of the digital programs managed by HADEA. Horizon Europe, Digital Industry and Space Cluster. HADEA manages 5.6 billion euro. Digital Europe program, 0.8 billion. and Connecting Your Facility, the digital sector is where I'm working. We manage 1.7 billion euro. So I'm presenting a call that will be open soon. It's called Operational Digital Platforms, and it will have a total budget of 19 million. So right now, during this autumn, probably in October, the call will be open for a first phase, which will cover, will have a budget of 4 million euro. And what we intend to finance is operational digital platforms. They are defined in the call as physical and virtual information communication technology resources operating via the communication infrastructure with support flow, storage, processing, and analysis of transport or energy infrastructure data, or both. So why are we financing this? Of course, to support EU environmental, energy and digitalization targets by providing technologies and connectivity to enable cybersecure Internet of Energy and optimize transport systems along major European paths. The idea is to retrofit existing energy or transport infrastructure with cross-border digital infrastructure. So, coming back to the discussion you had, actually, the idea is to build on existing and emerging European data, cloud and edge computing and connectivity infrastructure, in particular supported by Horizon Europe. So I think you have presented some examples that could be operational, what we mean by operational digital platforms, and that are being supported, will be supported by CEF Digital and are being supported by other programs, also Digital Europe program. So with this call, we also intend to do some cross-sectoral synergies within CEF, because it targets, as I said, the digital, the energy, and the transport sector. The call is designed in a way that has two phases. The first phase is the coordination and support action, and this is the call that will be open in October for 4 million euro. And the aim of this call is to prepare for future works proposals. So what we aim is to actually go a step farther in the deployment of what will be funded at the end. So the initial idea is that there is a consortium has to be created, and it has to cover the three sectors: energy, transport, and digital. This consortium will then prepare for the future deployment of projects, and the way it's designed, the call is designed, is that this will be done in 4 different stages within 27 months. The first phase is the exploratory study phase. So here the idea is that the consortium itself, covering the 3 sectors, identifies the needs in both sectors of infrastructure for cross-border digitalization, and let's say already designs or defines what would be the criteria in which the future works projects will be selected. It could be maturity of the projects, it could be higher degree of market failure. The idea is also in this exploratory study phase to see a bit what technologies will be used, but at a very high level, because it's to be done in 5 months, so record time. And then there will be 6 shortlist cases in this period that will then go to a feasibility study phase. For this feasibility study phase, the consortium can subcontract or use external expertise. And the idea is to already define the architecture to be used and the governance scheme, and to do cost-benefit analysis during this feasibility study phase in 7 months, and then 3 projects would be selected. So for these shortlisted cases, these 3 cases, there will be a next phase, a detailed preparation in 9 months, where further design, let's say further definition of the technology to be co-funded will be to be funded, because it's 100% co-funding, right? So will be deployed. We cover hardware and software, hardware, sensors, actuators, servers, substations, etc., and also in software, cyber security tools, artificial intelligence algorithms, simulators, etc. And later on, let's say after this detailed preparation for the 3 short lead cases, there will be a new call that will be open, where assistance will be provided also for further definition of the pipeline of the projects, and then there will be around 14 million available to fund these projects. So this is basically the idea. As I said, in October, the call is open for the first phase, meaning the coordination and support action for 4 million to create a consortium covering the 3 sectors. The deadline will be in February. More information will be provided during an info day. The date, I'm sorry, is not yet clear, but it will be in October, but we will give the info via CINEA. We have a very good cooperation, so it will also be published in our website. It's important to know also the requirements of consortium composition: minimum 5 applicants, beneficiaries, not affiliated entities, from 3 different member states. And here there is an overview. Let's say CEF Digital is covering, the first calls of CEF Digital just took place. We are now in the selection phase, and we cover other topics like 5G corridors for transport paths in road and rail, connected automatic mobility and road and rail, smart communities, so 5G for hospitals, use case to identify use cases, also for services of general interest, and also backbone networks for pan-European cloud federations. And this is also, there are submarine cables for digital global gateways. So I'm not going to go into detail on this. You will have the slides. I will be available as well during coffee and later on. If you have questions on the call that will come, or it's also a good opportunity to ask me before the call is open. You can also contact me by email if you have questions on the concept. And after, of course, is via these HADEA CEF Digital calls, you can also ask the questions, and we will be happy to reply. I hope you will be motivated to belong to a consortium, create a consortium, and apply. And I'm looking forward to future cooperation. Thank you very much. See you.
Before the event concludes, I'd like to ask Uroš Kerin, Assistant Director of the Asset and Project Management Division, to give us a summary of the key takeaways from the first Smart Grid PCIs Summit.
So, good afternoon. I started with good morning, now it's afternoon. It was a very dynamic day, as we all saw in the morning. It started to rain, now it's stopped, I think. I just don't know whether these were the tears of sadness or happiness of the environment. In 2015, on this very day, Queen Elizabeth became the longest ruling monarch in the history of United Kingdom. It was a record. And I believe today we also heard a lot of nice words about different records that any of us, of you, achieved during your projects. Maybe we did not talk about much of them, but when I see faces, some are happy, some are a bit less happy. I know that you are aware of what you have achieved and what your future plans look like. It's not an easy job, although we are now all having fun. We will have something to eat and we will have a piece of cake or a coffee. But nevertheless, being an engineer and translating ideas into practice, into actual world, it's not an easy task. It's very difficult. And if previous or history was all about electrification, so the last 70 years, which brought us into the position that we can enjoy today, we were never as rich as we are today as a society. We need to take really good care of this. Yeah? And I believe this day today is one proof that we are at least trying to go into the right direction. We never know. That's why we need to take small steps in order, if we make mistakes, we can go back and go somewhere else. If we do big steps at one moment, we can fall into, well, I will not say a trap, but into a position we don't want to be in. We had 3 panel sessions with more than 10 presentations. These were not 10 projects. Many more projects have been hidden behind the presentations that were presented here today. It was also mentioned during the presentations that, at least in one of the last ones, I believe, that the consortium had about 30 partners. Can you imagine? Have you ever tried project management with 5 people? 10? Your colleagues? 20? Imagine 30 partners from different parts of Europe. Different languages, different cultures, different problems, different ways of doing business. Well, that requires a real person. And I guess today we have some of these real people here. I would say, also maybe you realize this by my questions in the morning, that more than 1,000 people, I will not say 2,000 because, well, I might make a mistake about that, but I would say at least more than 1,000 people were involved in all these projects. I cannot even imagine how many companies directly connected or indirectly connected. We saw many, or we heard many nice words about use of state-of-the-art technologies, which are available on the market, but some of them have also been developed during these projects. Try doing innovation yourself. As the nice lady before us told us, innovation is all about finding how it's not possible. Yeah? Only the lucky ones, after 10,000 tries, find one way that's possible. And we all like to talk about that thing. We forget to talk about the ones that did not succeed. Not to point fingers, but to learn, because we need to learn from mistakes. Yeah? So mistakes are equally valuable as achievements. Don't forget that. We heard a lot about new developments. I really like that. I saw the Statcom hybrid solution somewhere. I don't know where the gentleman is. Because I was, during last week, I was in Sigre, Paris, and I saw at least 2 solutions that looked similar to that. But I'm not happy because I saw now, okay, we have a 3rd one. I'm happy because the 3rd one was developed totally independent from big vendors, which means that it's a new competition. It brings something additional to the market. And don't forget, 30 partners developed that, not one vendor. And that's remarkable. What we also saw today, and we see in the industry, is a huge, huge, huge knowledge transfer. Not among us. This is happening every day. But by buying complex solutions, doing complex projects, basically we grow. You can buy a fast car and you put it into your garage, but only the best drivers can drive the car in the right way. And for that you need to learn. And this is what we are doing by buying new devices, by buying storage systems, by implementing solar. And it's not everything nice. Also bad things happen, but again, we learn from mistakes. And it's not only about the knowledge transfer, it's also about knowledge buildup. I'm not sure if you saw this, but I see an increasing trend in Europe. TSOs and DSOs are following, are not only companies to transmit electricity from one part to the other. They are really becoming knowledge hubs. If engineer of the past needed to know what electricity is all about, engineer of the future needs also to know how this correlates to IT, how this correlates to environment, how this correlates basically to all different sectors of the industry. Again, it's not an easy task. So you can tap yourself on shoulders, you can give yourself a hug because you guys are really good. And you know how it is? To become smarter, you need to play with smarter people than you are. So when we hear about procurement problems, when we hear about legal problems, well, those guys are still smarter than you are. Yes, but you learn from them, and you are becoming smarter by the day. Also, in my case, I never knew I will know so many laws as I know today, because I did go through several procurement processes. It's a good thing. I have a few more gray hair, but it's a good thing. Yeah. And to conclude, and basically also to say that Europe is, at least in my observation, and again, maybe I'm not the reference, but at least I see this, well, we have something that maybe other regions in the world do not have. We are smaller than Australia in terms of continent. Can you name the figure how many nations live here? How important it is to cooperate? How important it is to translate this cooperation into technologies that makes our lives better? Nobody else has this on this planet. Remember this. Yeah? Not on such a geographical area. And we could do much better. So let's talk about the things we don't do. We talk to each other. We tell each other, oh, we are really good. No, you need to compare yourself to others that you don't see every day, because they will challenge you. Yeah? So we need to travel. We need to go to Asia and promote our projects. We need to go to China, to Australia to promote our projects. We need to go to the US. Well, then you see the actual improvements, achievements, and so on, and their value. And this is what exactly we are doing. This year, we had two projects. Let me see. From Horizon 2020, XFlex and Compile, which have been presented in US at the conference with more than 3,000 participants. But these were the only two projects. If you counted how much money Europe invested in those projects, well, my gut feeling would be about 500 million, because I was summing up the numbers. Can you imagine how much money that is? Go out and talk about this, because maybe we can do much more for less, or with what we get, maybe we can do even some other things. So I'm offering you here an opportunity, because I was challenged by the lady before me. It's nice to have all these summits and forums in Europe, but again, we need to compare ourselves to the world, because in terms of innovation, intelligence, and all the other things, we are comparing not with each other, but with the world. So I'm offering you a hand, and I'm inviting all of the speakers that are interested to be part of a panel session, next year in Orlando, Florida, on the IEEE General Meeting. To contact me, I will try to, bring you along. Mate here was also already part of that, so he knows what I'm talking about. And there we can see if European projects are really the best in the world. Thank you very much.